Here we're going to calculate the entropy departure function when we're given information about the entropy at a couple conditions. And the idea is we're going to write down the condition we're interested in. Let's call that 2. So S2 minus S2 ideal gas. That's the departure function we're trying to calculate. And we're interested, of course, at 300 degrees C and 30 bar. We're given this value here, 25 joules per mole Kelvin. And then we know the entropy, and let's call this, let's call this condition 1, where this is 1 bar pressure and 250 degrees. So that's, we're told, is an ideal gas. And that entropy is 45 joules per mole Kelvin. So that's 250 degrees C and 1 bar. So what we're going to do is, since we know the entropy for an ideal gas at one condition, we should be able to calculate the entropy for an ideal gas at other conditions. So S2 ideal gas should be S1 ideal gas, and then correcting for the pressure difference between 1 and 2, so log of pressure 2 over pressure 1, and correcting for the temperature difference, log of temperature 2 over temperature 1. And so we substitute values in here. S2 ideal gas is going to be equal to 45, and we're using joules per mole Kelvin for entropy, so that's units for R, and then the log pressure for S2 is 30, pressure at S1 is 1, and then the heat capacity is given again 30 in joules per mole Kelvin, and the log temperature 2 is 300 C, so 300 plus 273 to make it Kelvin, and the temperature 1 is 250 degrees C, so again making it absolute. So I can calculate these numbers, and let me just pause and put them in. So we have S2 ideal gas, and of course we have S2 when we started, so the difference is the departure function, and that's what we're interested in. S2 minus S2 ideal gas becomes 25 minus 19.46, which is 5.54, and significant figures, let's write that as 5.5 joules per mole Kelvin. That's the entropy departure function, 300 degrees C and 30 bar.